Okay, sure.
All right, so make start again. It's fine. It's fine if this
Alright.
mic doesn't pick you up. You need the Zoom mic to pick
Alright,
you up.
so
Otherwise,
let's-
the recording won't
Give me a second. Okay, so. Alright, so for this specific workshop, is a, oh, thanks. Can you turn it off? I don't really want to.
Just skip here. All right, you'll be fine.
Alright, so for this specific workshop, I'll be using Visual Studio Code and Node NPM to create a website. And to start off with, you would want to go to Visual Studio Code and open up terminal. And then you would run this code npx create -react -app. And then instead of my app, let's choose a period instead. This will create a React app in this current directory. So let's try it out. Okay, so now we're initializing the app. So right, forgot about that.
It's like, this is like, this feels like a random. That's not what I do. You're doing it very fast.
Let's try it one more time.
You're very small. The fact that it's called the amount of work that we do all. Think about. This time, yeah, I'm like.
Alright, back up. Okay, so let's run this piece of command in the terminal. This will create a new React app for you. It's called npx create React app period. So you can take a look at this. Then once you press enter, it will start creating a new basic React app for you.
Yeah, I know.
I'm just gonna wait for this to finish.
No, actually, I took another hackathon.
All right, it's installing the dependencies. So it's gonna take a while.
That's a definition of. So what we should take it on. If it's my end, yeah. We should have used that. Hold on. Phones and my phone fast.
Okay, halfway through. All right, it's done. So now you should see a project on the left. Let me use annotate. You see a bunch of files and folders on the left, okay? It will look slightly different because I customized my Visual Studio Code a little bit. But generally you will see node modules, public and source, okay? And what we're going to be mainly focusing on is the source folder because that's where most of your code will be placed in. All right, so let's go into the source folder. You can see that there's a lot of different files for web design. For those of you who haven't really done any web design yet, I'm gonna explain to you what some of these files do, okay? So index.js is the entry file, okay? And anytime somebody loads into the website, the first thing the browser will load up is index.js. So you use index.js to load up every other file or like, subpage inside of your domain. Okay, so right now what we have is we have a root into the app component, which I'll talk about in a bit, okay? Okay, so I'm going to go back to the terminal and type in npm run start. This will host the website on your local computer, so you can preview your changes, all right? So let's run it. It's going to start compiling soon.
I already said that. Because we don't really need to sit that much. We already have all the. Yeah, we can read off.
All right, there we go. Should theoretically open in the browser. There we go. So this is what the very first website looks like at the beginning. This is the basic starter website template, and you'll be able to modify it to create what you would like. Okay. So the report web vitals thing isn't that significant, but usually I would put console.log inside of here, which means that it will print out any issues that it encounters into the console. All right, so next up, we're going to go to the file called app.js over here. This is where most of your website data will be placed in, or website components. And this will also define what your website looks like. Index is just a root to everything that's really relevant to your website, while app is the website itself. Okay, so over here we have different tags. If any of you guys have learned HTML, you will understand how it works. So inside of, let me create a bunch of new lines. So instead of JSX, you will have an opening bracket and a closing bracket for all of your content. Okay, for example, div elements will always have a closing div element. Okay, so over here we have the opening div element that looks like this. As you can see, there's I don't forgot what to call these, but there's these two closing and opening brackets. While over here there's a slash indicating that this is the end. So this div bracket will start from here and end over here. And then you can place other elements in between these two, such as this. Then now we have a header one bracket that closes at the end over here as well. Okay. So these are how brackets work in HTML. And you can always put things inside the brackets, such as text or other tags. Okay. And if I save this, it'll update at the very bottom over here. My first React app, which is over here. It's not quite styled because of how I added it. If I took this and I moved it into the header counter, it would look like this. All right. So now let's see what else I want to go over. Okay, yeah. Next I'm gonna go over the CSS. Okay. So CSS is basically styles for your content. Okay, HTML basically defines that there's this amount of text in this position, but CSS defines what it looks like, such as where it's placed, any animations, its color, and other stuff like let's see, color, font size, content position, and keyframes like the animations. Okay, and you can always, and they're defined into something called classes or IDs. Okay. So you can put classes into your components like this. Class name equals app, right? And then that means that it will trigger this specific style, okay? Which means that everything is aligned in the center because this is the app class. Since this is the app class, it will be applied to this div element here. And you can add and I didn't go over this, but you can add properties to your tags by doing something like this. Property name equals property value, which can be a string or a value enclosed in brackets. All right, let's see what else I want to talk about right. There's also like other imports you could use. So at the very top, in order to use specific CSS, you would have to import the said CSS into your file. And then by doing that, you can add in the classes or styles defined by the CSS into your JavaScript code. Okay. And you can also do functionality such as use state. Okay. So use state on clicked set clicked equals use state false. Okay. So these are states. So this is a value and this thing is a setter for the value. So if you take this, if you call the setter, this value will change, which I'll show you in a second. Okay, this is a bit complicated, but I'll explain it to you in a second.
How do you think you did on that?
Okay, so I created a new div element that has a function called onClick. So when it's clicked, it'll set clicked to true, which will set this value to true, but when it was initially false. And if it's false, it will say no clicked, while if it's true, it will say clicked because it's a ternary operator in JavaScript. Okay, so let's take a look at how it appears. Right, works perfect right now. Let's try one more time. You click it, it becomes this value. Okay, so that's how states work in JavaScript or React. You have a value and a set value and an initial value, and then you can use it directly inside of the code underneath. Does anybody have any questions? Right, great. Hold on, give me a second.
There's no.
Okay, it's no, but you need to record it. Otherwise, you don't get the audio, no? Yeah, I'm gonna restart. I unmuted from here. Okay. Okay. Can you screen share that?
We need a social.
All right, so we're gonna talk about GitHub. What essentially GitHub is it is a version control software, so source control. So what essentially that means is that you have your code hosted on the cloud, and basically, essentially, every time you make changes, you make pushes to that cloud to override your old code. And what essentially it does is it keeps a history of everything you've done. So if you need to revert or something like that, you could do that without any consequences. Because sometimes we all know you implement a bug or something and you don't know how to fix it, you can always just go back a few hours to your code when it was working. So I guess yeah, we can start with GitHub repositories and stuff like that. So yeah. Yeah, I'm gonna just put this in. Sure, I don't know why I took it off. Right.
All right, so first step to creating a repository would be to have an IDE. So in my case, I'm going to be using Visual Studio. So to create a repository, you would need to download GitHub Desktop. Should we send it in chat?
Yeah, I guess GitHub Desktop. Yeah, we'll send that later. But also you could use the GitHub Desktop to create a repository up here in this icon. You click add and then create new repository. Or you can actually as well go to the GitHub page and then click plus and then new repository. So without further ado, I guess we could just make one and then go into talking about pushing and pulling.
All right, so I'm just going to create a new repository called test. So once I click new repository, GitHub Desktop will put me in this repository where I'll be able to control my code, control all my branches. So to open this repository in my IDE, you'll see this little button here called Open in Visual Studio Code. So I'm going to go ahead and click that. And here we go. We're in Visual Studio Code. So the power of GitHub Desktop is that, like, let's say I make a change in this IDE. These changes will automatically update in GitHub Desktop, where I'll be able to push the changes. And it's pretty much like a Google Docs of coding. You can revert your changes. You can see what changes are being added. And it's overall just a great way to organize all your code. So I'm going to go ahead and create a new file here. Let's just say I want to create like a Python file. And let's see.
I guess I could also give a little bit of background of what GitHub is while he's doing that. So basically GitHub is a software which is actually used a lot in actual industrial standpoints as well as computer science. So it's a good tool to know, or just version control in general. It doesn't have to be GitHub. You could use Atlassian or Source Tree, which I think is also GitHub, but it's just a subranch of it, or Bitbucket. However, source control is just a practice used in the industry for multiple people to collaborate at once through pull push configurations. So for example, let's just say that he made a change. It will be updated on the branch in the cloud. And then what I will do is I'll have to pull it. So I'll get a notification on my side of the GitHub desktop of the repository. And then it will prompt me to update my local code repository with the changes that were on the cloud. Now, you may be thinking, why isn't it just like live, just like Google Docs? The thing is, sometimes people do have to work offline and sorry, what's going on? So sometimes people do have to work offline, and this would cause some problems, especially with being connected all the time. So that's why there's a push-pull system. And also the push-pull system maybe then would cause merge conflicts, which is something that happens when two people modify the same file at the same time. GitHub tries to address this as much as possible by combining what the two people wrote at different time frames when they both try to push together. And however, if two people modify the same line, that will have to be manually addressed. So we'll talk about that as well later.
All right, so here in this example, what I did is, let's say I want to import by auto GUI. I spelled that wrong. So if I save this to my local device, what will happen is GitHub will automatically update the file. And from here, I'll be able to push my changes to the main branch. You wanna?
Okay, so this box right here is a commit message. So this is really useful for if you're working with multiple people. You could say maybe you committed a version, maybe you fix something per se in like a map application, and like the map, maybe there's a bug, maybe you fix some pins, or maybe you added like a menu option. So you could like type what you changed in this commit just for other people's reference or even yourself. But sometimes you go out with spam. And what you do after you type in a commit message is you click commit to main, and then you actually end up clicking push to origin as well. So what's the difference between commit and pushing, you may ask? Committing is that you're storing a snapshot of the current changes in your repository on your local device, and pushing is you're sending that into the cloud. So sometimes, let's just say you're offline, you got multiple commits on your local device that you could then roll back to, rather than having to be connected to internet to do online push pull stuff, and then also reverting from the GitHub website. So now that we pushed it to actually GitHub, you actually right click on this on the top left panel, and you can actually click view on GitHub. So this will actually pull up the repository in the GitHub website under your profile, which is shown here, and then the repository name. So as you can see, you just committed with that commit message just like a minute ago, and now the test.py file is now available on the GitHub repository under the test file, which was just created.
All right, so that's about it for pushing. You'll see that if I click this file, it has my import that I did in my local system. So GitHub is also pretty powerful for, let's say you want to use someone's example code. So there's actually a really powerful tool in GitHub called cloning, where you can pretty much clone someone else's repository and their code. So to do that, you'd go under code, and then you'll see this little open with GitHub desktop option. All right. And by doing that, you'll be able to access someone else's repository in your own GitHub desktop. And if you follow the same steps as before, open in Visual Studio Code, you'll be able to gain access to their code, all their algorithms, etc.
So essentially, yeah, basically you're downloading a copy of the online repository when you do cloning. And also, I guess we could talk a little bit about conflicts. Not, I guess, going to get super in depth about it. So on GitHub, you actually modify the files that you sent in. So per se, you want to add a README file. So there's also a commit button up here, just like that there was in the GitHub desktop application. And there's also a commit message box. So when you commit a file onto that, you're doing it from the website or someone else on your team doing it from their computer, it's going to cause an update that you're going to have to download basically again from the repository. So if you fetch, you click that button, it's going to say pull origin. What that essentially means is that there's been a change on the cloud while you were gone. Someone has modified something and you need a pull to be updated. So just as demonstration, we just inserted a README file, right? So let's just open this in Finder. That's going to take a little bit. Okay, so you see that there's only test.py here as a file. What you do once you pull is now you're going to see that the README file shows up because this got downloaded. This is a change that happened on the cloud that is not present on your local machine. There's also a possibility, right? Like I said, with like the merge conflicts. So per se, if you edit something here or someone on your team does that, and commit the message, and then you also do the same thing on your local end with the on the local end as well when you change some code, I guess, on your side on the same file, and you try to push, but the other side, but the other computer or like on the cloud has already been modified. You'll see that there's a message that tells you to fetch. Then it wants you to resolve the conflicts. So you can see that there's a merge conflict. Now GitHub Desktop is going to try to do this automatically for you. However, I modified the same line, so you might have to resolve it manually. So as you can see, it says open Visual Studio Code. So there's actually a merge resolver in here. You can accept what you did currently on the local machine, accept incoming change. So whatever someone else did online, accept both changes, which is just just conjoin them or compare the changes if you'd like. So this is a powerful merge resolver. And then once you actually fix this, I'll just keep in mind for now. It will actually say that your merge has been resolved. Let me just Control S to save it. Okay, so yeah, you see that check. That means that it's done. So then you could commit, and then you can send both the files after you fix the merge conflict back onto GitHub. So if I refresh, yeah, it changed to the one that was on my local machine. So this is useful per se if there's different sectors of your project that are doing different things. So for example, if someone's coding a bow and arrow and someone is coding the character walking animation, you guys could be doing that at the same time in the same project, or maybe even accessing the same file per se, like the character has to shoot the bow and arrow, and then the bow and arrow is being modified by someone else. They could use this merge resolving system to see what was being added and what they're going to be overriding. Yeah. Yep. So I guess without getting into too much depth, that's really most of it. There's also branches, but I mean that's I guess a little bit more complicated. I think this would be like a starter workshop that would get you, I guess, ready to just use GitHub in general. There's also issues where you could file issues in like a project, in like a bigger project. You use them under this Kanban board for project management as well, and just to keep track of what issues are, known bugs and stuff like that. But that's also more advanced. I guess just for like hackathon based projects or just for like beginner projects, just knowing the clone, push, and pull functions are really critical. And if you're working with someone else, the merge functions as well. So yeah, I think that concludes our workshop with the GitHub. Yep. All right, yeah.
Wonderful.